Yeah, Shubhangi. I want to say something. You have raised hand. I think you want to say. So if you want, you can unmute and. So welcome and good evening to everyone. So, so this is the fifth session, fifth problem solving session or discussion session, whatever you call. So today we will. So yes, last day we finished at solving the problems of second week of last year. So very interesting session it was. Everybody I think got engaged and uh, tried to solve few problems. I think that will be really helpful to you. Uh, so the plan was that we will not talk about the week three because that is totally history based thing. So there's nothing to discuss more. You have to read and then answer the memory based or data-based questions. So that was decided that we'll not discuss on that. So we'll further discuss on. We thought of starting from week four, but week four was actually the extension of week three. Right, the mostly the history part is there, although in the in the last section there is some interesting thing is there. Not I would not say like that, but yeah, some things that we can have a further discussion or in the like a discussion forum like this session. Okay, so there that's why I thought of starting from week. I will starting from that part only. That is the later part of week 4, and then we'll move to the week 5 basically. We'll try to discuss initially that a few of the things that is related that was taught in week 4 majorly, and some part of week 5 majorly, and some part of week 4. So I think I've managed to add some slides on that. I've collected it from different sources as well, and so hope I will quickly, not quickly, I will try to go through that one by one. I think some of you have had some questions or queries and written to Professor Swamitra sir. So he talked to me also and talked to all the TAs actually. He said that it will be better to discuss those things. So I'll try to discuss, but first we'll go through these things. We'll try to solve the problems of week 5, and then we'll discuss those few points that I think some answers of the assignment that uh, someone was has some confusion. So that will be discussed anyway. There's no problem. So we'll first go through those sections, or especially a quick pipe about hypothesis, and but before that, what scientists do and all. So those things I'll try to quickly go through few slides and then go to the hypothesis section. Okay. So that is the plan for today. So I'm then presenting. That will be helpful. I think many people have joined already, and people will keep joining anyway. Okay, so the slide is visible, right? Anyone just confirm? Hello.
Yes, sir, it is visible.
Okay, 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 okay. Thanks. Is the problem? Okay, so the in the fourth section, or the rather fourth chapter, so it was that initially we taught about some of the historical background of this part, and then it, it was taught that what scientists actually do, what is this, what is about scientific methods and all. So this part I'll try to go through a bit. Yes. So what scientists actually do? So till now, what you have read about many things like what is science and why, what is philosophical foundation behind that, what are the logical reasoning, and for logically solve some problems or issues, we have read different hypotheses or postulates, and then we have tried to solve the syllogism problems with Venn diagrams. And so now, actually, we need to discuss what scientists actually do. What is the scientific methods that we all talk about throughout these sections? Okay, so what scientists actually do? So what is scientific method? So scientists actually do. So they ask question. That is, they ask question on some aspect of nature or natural phenomena or society in a, so that they can get some answer. So how to get answer? For answer, they have to categorically analyze the problems or the issues they have raised based upon the literature or the previous record that is already available, done by many people or many scientists rather, and then based upon some experiments can be designed or can be newly designed entirely, or take inspiration or help from this literature. And based upon those results, they have to analyze logically that logic you have and we have taught earlier. Based upon those, they have to come to a conclusion, and then that will show some result or some trend. So then from there we can conclude what inference that is. So that is very broadly we can say. Okay. Now, if we say from some source that what is scientific method, so the scientific method is the process of objectively establishing facts through testing and experimentation. The basic process involves making an observation, forming a hypothesis, making a prediction, conducting an experiment, and finally analyzing the result. The principles of the scientific method can be applied in many areas, including scientific research, business, and technology. So, yeah, so what I was saying. Now, what are the steps of scientific method? So there are steps, those are already mentioned. So you use a series of steps to establish a fact. So that, and when scientists or some scientific experimentation reveal a fact, then that leads to a data, or what will I say, that confirms some so that confirms so that gives actually some knowledge that will be helpful for the upcoming or further people who will work on that particular area or field. So the overall process is well established now, but the specific of each step may change depending on what is being examined and who is performing it. The scientific methods can only answer questions that can be proven or disproven through testing. So that is the main thing. You have to test, you have to experiment everything so that you can get some data and then analyze and get some conclusion. So that is the prima facie of this section. Now, to if we broadly describe or broadly categorize this section, so this is the overall process of scientific research. That is, first you ask a question. So what we do, what scientists do. So they try to focus on a particular question that is still unsolved, or that has not been research on the house have been searched by any of the or previous scientists or scientific workers. So they try to find that kind of question in that perspective, or they might find a question that is creating that will be helpful or beneficial for this humankind. From you can ask, or you can define a problem, or you can try to find a problem for research from many perspectives. Okay, either you go through this literature, then you see that there are, okay, this kind of problem has not been solved. You don't know either that will be your search will any at all help, will be helpful or not. It might not be that much helpful because that is a redundant, although that will be an addition of a data, but that might be redundant. But uh, in that way, many people do. But the main focus always lies in the fact that some problem that will be either very fundamental in the science, that might not be directly beneficial for the society, or but can be beneficial for some people who will further work on it. Let's say for some laws, or for some very basic principles. So you can say that what is the application of that. You can directly ask for very fundamental questions when when something like that is discussed. But then that scientist cannot directly answer that what is the direct application of that. It is not like that is it will directly it will be applicable. But what is the case is that from different field or the upcoming scientist who can take it to its actual application. So in that place it might be helpful. Okay, as a literature, it might guide as a data, so it might be helpful like that. So first tick box is to ask a question or define a problem. Then Now once you have thought of, okay, I will work on this, then you have to do a background research. What are the literatures available there? You have to thoroughly go through that what, I mean, what kind of data are there, what kind of results are there, that will help me to propagate my this problem that I have chosen to work on. So that is the second thing. Then third is form a hypothesis. So you have chosen a question, a problem. You have taken a problem, then you have searched literature, that you have found out, okay, this much work has been done, but okay, in this way or in this particular thing, as people has not searched properly. So, and this might be useful, so I will work on that. So for that, you have chosen your own materials, like, let's say, what do let's say, that since I'm a chemistry student, let's say biochemistry student, so there you might think that, okay, so people are showing that this kind of some kind of molecule showing chirality. Okay, chirality. I mean, it's not necessary to know all of you to what is that, but the thing is that let's say chirality is a term that is generally used in this field. So, so people are working on the property of some particular molecule. Then, so they have thought of that. Okay, there is a problem in this humankind like that. So, what kind of what kind of uh, sorry, what kind of molecule might be helpful for the treatment of Parkinson's disease? Okay, so there's a molecule called or a compound called L-DOPA. Okay, so that I think might some people might know that. So okay, so the people have thought that how it's why L-DOPA is required. L is a notation of chirality. There is L and D. So some people who have worked on that might have thought, okay, I'll try to think how to solve the problem of this kind of disease. So he might have worked on many molecules. Then he thought he could have come to a conclusion, okay, so for solving this issue, some this kind of solutions are required. So that is called a hypothesis. Okay, so that is the hypothesis for this solving this problem. This kind of molecules are problem. So I am telling it in terms of chemistry since I am from chemistry background. But people, you can just take any example from any of the backgrounds that you are from, right? So now this part is hypothesis. Okay, so then it will come to the next section, that is test with an experiment or data. So that is the most crucial thing. So for that you have to first categorize your things, what to do. So you have to set the experiments, you have to do the experiments. Let's say for this, from the literature, he has got some idea of some molecules. Then he or she has taken that molecules and tested that, the chirality of that and the applicability of that. And then that is the experiment. So what are the experiments? That will be based on, again, the literature, or he might design new. So that is the case. So then he will test, and from this experiment he will get some data or result. So then the next work is to analyze the result. So when you analyze the result, you can there are two possibilities are there. Either it will be accepted or it will be rejected. So accepted means, so whatever data you have got, so you have given a hypothesis, right? So for solving this issue, so a is required, a this kind of molecule is required. But from the data you have found, so this was your hypothesis, right? So but you have found that no, actually a star is required, not exactly a, but a star. So then your hypothesis is rejected. And but if you say, okay, a is required, then it will be accepted, right? So that is the case. Then so here you can see that it is written that if it is rejected, then you have to, if it is accepted, sorry, then you can report that data. You will try to communicate some paper that will be accepted. So that is a different process, I'm saying. But okay, so then people will try to give some more analysis, get some more analysis from you. Then they will confirm that okay, whatever data you are getting, that is well enough, and your hypothesis is correct. So then, once that is accepted, it your paper or your whatever work you have done, that will be accepted in some journal. So then, once it is accepted in some journal, then it is a literature. It is come on into a literature. So people can access that, in that is in the public domain. Now, but if your analysis or your data is rejected, I mean, rather, hypothesis is rejected. Whatever data you have gotten, if that is not concluding to your hypothesis, then you have to replan. You have to think again. You have to replan your sorry. You have to rephrase your hypothesis. Because since you are sure that if A is the molecule, so sorry. So solving this issue, A will be the molecule that will be beneficial. But you have found out that not A star is beneficial. So then it is not correct. So you have to revise that thing, and you have to revise your hypothesis again. If required, some experiment has to be done. But finally, it should be that your hypothesis has to be accepted by the experimental result. Okay. So that is the case. So this is an overall scientific method that scientists work on. So based upon this, there are some things that needs to be addressed next. Okay. The next, what I have discussed till now. So these are written here only. So make an observation or ask a question. First step is to observe or something. So then gather background information, then create a hypothesis. So a hypothesis is an explanation for the observation of questions. If proven later, it can become a fact. Or some examples would be like our employees watching online videos during lunch is using our internet bandwidth, or our website visitors don't see or register. So these kind of things. So these are the hypotheses. If this, then this happens. If this occurs, if A occurs, then B happens. So this kind of things. Then create a prediction or perform a test. There's an experiment and analyze the result, and finally draw a conclusion based upon that, as we have talked about in the sections. Now, finally, the final thing is that share the conclusion or decide what questions to ask. So once you, once you're sure about the data or whatever you have gotten, then you have to take bring that in the public domain by making the paper or the work communicating in some journal, so that the journals accept. And so that is the overall process. Now, so share the conclusions or decide what questions to ask next. Now document the results of your experiment. By sharing the result with others, you also increase the total body of knowledge available. As I said, it will be now be in a literature, so it will be in public domain, and people can access the result or hypothesis. Now the thing is that new people or the your successive people can come again and work on that field, and they can find that okay, that was whatever conclusion you have drawn from your data. So that was not actually correct. It might happen. Okay, that will come. So that is another fact that is very relevant. So that can happen, but that is no matter. But whatever you have your experimentation and your understanding told you that you have taken in the knowledge of people. But again, that might be wrong. So that has happened. I mean, that is actually the science. In that way only science progress. So your experiment may have also led to other questions. Yeah, that is another good point, that it might raise some other questions, or your hypothesis or your experiment, or rather the experimental results. So I mean, some unsaid or very unsaid nuances that was there that you might have you might have overlooked. That can happen. So but some people who are analyzing the further the data, they might get catch that, and they might say that okay, this was also the case that was happening there. Or if your hypothesis is disproven, you may need to create a new one and test that. For example, because user activity is not the cause of excessive bandwidth use, we now suspect that an automated process is running at noon every day. So that was the example that is given in the earlier slide. So this is the overall case of the scientific methods. Now for these different things are there, like yes. So so different aspects are there, like how to do this kind of, how to hypothesize a thing, or how to do a hypothesis. What is hypothesis? What is postulate? How to propose a postulate? So what is the measuring value? How to test? So these kind of things are there. So these will be discussed anyway in the further upcoming sections. Now, first I will talk about today about the about postulating about forming a hypothesis. So what is hypothesis? So, hypothesis is an assumption that is made based on some evidence. This is the initial point of any investigation that translates the research questions into predictions. It includes components like variables, populations, and the relation between the variables. A research hypothesis is a hypothesis that is used to test the relationship between two or more variables. So, what we were talking in very linear terms, so these are now coming in very context dependent terms, right? So, these kind of terms like relationship between different variables. So, that is a hypothesis. Okay. So, a hypothesis may be defined as a proposition or a set of propositions set forth as an explanation for the occurrence of some specified group of phenomena, either asserted merely as a provisional conjecture to guide some investigation or accepted as highly probable in the light of established facts. For example, consider the statements like the following one. Students, so you understand, right? So hypothesis may be defined as a proposition or a set of, so it can be one single or multiple set of propositions set forth as an explanation of the for the occurrence of some specified groups of phenomena, either asserted as a provisional conjecture to guide some investigation or accepted as highly probable in the light of, so basically some based upon some established facts or established or known data that is available. So this can be postulated. Okay, so that is the case. Now, for example, students who received counseling will show a greater increase in the creativity than students not receiving counseling. Or automobile A is performing as well as automobile B. Is a hypothesis capable of being objectively verified and tested. Thus, we may conclude that if a hypothesis states what we are looking for, and it is a proposition that can be put to a test to determine its validity. So, so um, all right. Yeah, okay. So, so yeah, so this was the hypothesis that we talked about. Now, next we're coming. What is the characteristics of hypothesis, right? So hypothesis must possess the following characteristics. So these are the some things that should be taken, that should be considered while you are hypothesizing something. Okay. So first thing is that it should be clear and precise. Hypothesis should be clear and precise. If the hypothesis is not clear and precise, the inferences drawn on its basis cannot be taken as reliable. Like you should be very so your hypothesis should be clear. Like if if A happens, then if A occurs, then the resultant result will be B. Like that, it will be very clear. Otherwise, if you vaguely say something, then that will be even the inference of that will not be taken as a result, or will not be considered well in the scientific community. Next, hypothesis should be capable of being tested. A hypothesis should be such that which can be tested, or against which some experiment can be done. Otherwise, it is not. I mean, if you hypothesize something which is not possible to test or experiment wise, then that will be anyway discarded. If a swamp of unstable hypothesis in a swamp of unstable hypothesis, many a time the research programs have booked down. Some prior study may be done by researcher in order to make hypothesis a testable one. Hypothesis is testable if other deductions can be made from it. Okay, now third point is the relationship between variables. So there should be some relationship if it happens to be the relational hypothesis, right? So this is the case. So that we talked about, and should be very specific. Should be limited in a scope and limited in scope and must be specific. A researcher must remember that narrower hypotheses are generally more testable, and he should develop such hypothesis. So okay. Further points, it should be hypothesis should be stated as far as possible in most simple terms, so that the same is easily understandable by all concerned. But one must remember that the simplicity of hypothesis has nothing to do with its significance. So it is that it should be very much doable. Or it should be, you have to hypothesize something which is possible, but it is not that it does not linearly dependent like that. If it is simple, then it will be very much significant, or it will be accepted. So simple doesn't mean that it will be accepted or significant. It might be wrong. Simple might be wrong, but it should be, you have to hypothesize something which is possible from the considering the background studies or the literature survey. Next, it should be consistent. It should be consistent with most known facts. That is, it must be consistent with a substantial body of established facts. So you have to taken care of the literature. What is there in the what is stated, or what results are already accumulated in the literature. You have to take care of that. Anything that is violating that, so that can be considered, but for that, you have to do a rigorous study, but you have to keep it in mind that it will be always remember while considering whatever work you are doing, the literature will be considered as a proven fact. If you have to disprove, then you have to go against that, and you have to do some. So it might not be, I mean, consistent. Yeah, it is very normally said it should be consistent, but it can be inconsistent, or it cannot match with the previous literature. But then you have to prove that very strongly. Okay, it should be one which judges accept as being the most likely. So judges means whenever you communicate something, uh, the reviewers. Okay, now the next is it should be is testing. Hypothesis should be amenable to testing within a reasonable time. So anything so this is actually vague, because anything, what time you'll consider. So anything you say, like let's say to take 2 years, 5 years, 10 years. So you don't know. And most important thing is that there are many aspects of a particular problem when you are addressing. Let's say a lab, when that is running, there are multiple people are working on there. So let's say the lab has a particular focus, so they will work on to achieve that particular goal. But to achieve that particular goal, you have to go through different steps. Okay, or you have to, let's say, you want to prove, you want to reach to a goal of D. Okay, for that you have to first prove A, B, C, then only you will reach D. So for to prove this A, B, C, then A must have some subset, B must have some subset, C must have some subset. In that case, people are working. So some are reaching to the subset of A, some are reaching subset of B. So so but what will be the time then? So this is a very very vague thing, but still there should be some limiting time, right? Or some time constant that should be considered to, because the thing is that these things are growing, or any thing, any research thing that is growing, that those are growing so fast that if you don't take that problem to solve within a particular time, I mean, that phenomenon might have changed by that time. It can happen. Okay, if you are not taking a very very fundamental problem. So that is the case. It should be, testing should be within a reasonable time. And further, the last is the hypothesis must explain the facts that give rise to the need for explanation. This means that by using the hypothesis plus other known and accepted generalization, one should be able to deduce the original problem conditions. So, thus, hypothesis must actually explain that what it claims to explain. It should have empirical reference. So, means whatever work you are doing, that for that some particular background or a particular literature data should be there, and based upon that you are working, so that whenever you are trying to show your work to the expert of that field, so that they can refer to some earlier publications or earlier results that have been already worked on, and based on that they can judge. Okay, so these are the things of hypothesis. Now, different types of hypotheses, what different, many different types are there. So these are very broadly have been done in a book. So that is simple hypothesis, complex hypothesis, directional hypothesis, non-directional, null, and associative. So these two are very important. We'll talk in detail about that, and before that we'll talk very briefly about the initial ones, right? So So till now, this is clear, right? Actually, I'm talking long. So any doubt or anything, you can tell. Okay. If not, then we can move further. Okay. So first one is the simple hypothesis. So it shows a relationship between one dependent variable and a single independent variable. For example, if you eat more vegetable, you'll lose weight faster. So here, eating more vegetable is an independent variable, while losing weight is a dependent variable, right? So this is a simple hypothesis. Mm, so so only two variable, one variable is there. So based on that, this is done. Next is the complex hypothesis. It shows the relationship between two or more dependent variables and two or more independent variables. Eating more vegetables and fruits leads to weight loss, glowing skin, and reduce the risk of many diseases such as heart disease. Okay, so earlier what was there? Only if you eat more vegetable, you will lose weight faster. So one dependent and one independent variable and one dependent variable was here. Two are there, like eating more vegetable, eating more fruits leads to what will happen? Weight loss and glowing skin, and reduce the risk. So two or more, right? So then this is the complex. Directional hypothesis, it shows how researchers is intellectual and committed to a particular outcome. Relationship between the variables can also predict its nature. For example, children aged 4 years eating proper food over a 5 year period are having higher IQ levels than children not having a proper meal. This shows the effect and direction of the effect, right? So this is changing with time actually. So with time, so basically when one can hypothesize something orthogonal based upon the literature data. Okay, now next is non-directional hypothesis. So it is used when there is no theory involved. It is a statement that a relationship exists between two variables without predicting the exact nature of the relationship. Okay, so these are not that much important as whatever we have discussed till now, but these two are most important. So null hypothesis and associative hypothesis. Okay, so we'll discuss in detail about null hypothesis and associative hypothesis. So what is null hypothesis? I will quickly say that it provides. Okay, someone is saying something. Shubhangi again raised a hand. So yeah, Shubhangi, you want to say something? I don't know. It says raised.
Nothing, sir. Nothing.
Oh, okay, okay, yeah.
By mistake, I raise hand.
Yeah, I understand. Okay, no issue.
Uh-huh.
So now, what is null hypothesis? It provides a statement that is contrary to the hypothesis. It is a negative statement, and there is no relationship between independent and dependent variables. The symbol is called as H0. Now, I'll come in detail anyway. An associative or causal hypothesis is an associative hypothesis occurs when there is a change in one variable resulting in a difference in the other variable. Okay, so we'll come. But before coming to these two sections, another important thing is there. Since I will discuss in detail about these two, another important thing is there. That is okay, so sorry. Before that, some aspects of hypothesis is given. Okay, that is how to write a hypothesis. So writing a hypothesis is essential as it can make or break your research for you. That includes your chances of getting published in a journal. So when you're designing one, keep an eye out of these points, right? So these are some important points that needs to be keep in mind while you are hypothesizing and doing in the all the experiments based on your hypothesis. That is, a research hypothesis has to be simple yet clear to look or justifiable first. Next is it has to be testable. So these are already discussed. Still, some these are some important points. It has to be precise about the result, like what exactly you want, what you're trying to do and achieve through it should come out of your hypothesis. Next is a research hypothesis should be self-explanatory. I mean, a hypothesis should be clear and vivid so that it can be understandable. It is understandable. Okay. Next is if you were developing a relational hypothesis, you need to include the variables and establish an appropriate relationship among them. And then a hypothesis must keep and reflect the scope for further investigations and experiments. So, okay, so anything that you are searching for or looking for and doing experiment that can be further expanded. Your hypothesis should be such that it is an open ended. There is some scope that can be further investigated. Now, as coming to this important fact that is this falsifiability. So this is very important. What is this falsifiability? So falsifiability is the assertion that for any hypothesis to have credibility, it must be inherently disprovable before it can become accepted as a scientific hypothesis or theory. So falsifiability means that there is always a scope that your hypothesis can be proven wrong. Okay. It, so if it is there, then it is hypothesis. Your hypothesis is okay. And
Sir,
if
Sir.
sorry, somebody saying anything? Okay. So, for example, some might claim the Earth is younger than many scientists state, and in
Sir, not
fact,
audible, sir.
oh, am I not audible?
We are audible.
We are audible.
We are
Yeah.
audible.
Okay. Okay. Okay.
Continue.
I think me check your connection. Might be some issue.
Yes, sir.
Okay. So yeah. So so the Earth is younger than many scientists state, and in fact was created to appear as though it was older through descriptive fossils, etc. So this is a claim that is unfalsifiable because it is a theory that can never be shown to be false, right? So you understand, right? So the earth, some scientists has claimed that the earth is younger than many the Earth is younger than many scientists state, and in fact, it was created to appear as though it was older through descriptive fossils. So this is some kind of hypothesis uh, which cannot be which is unfalsifiable because it cannot be tested, and so in that way, if the falsifiability is not present there, so the hypothesis is wrong. If you were to present such a person with fossil geological data or arguments about the nature of compounds in the ozone, they could refute and the argument by saying that your evidence was fabricated to appear that way, and it isn't valid, right? So you understand. So this is the case. So your hypothesis should be such that uh, it is falsifiable. So falsifiable. So a hypothesis will not be considered as a hypothesis unless it is falsifiable, right? So the falsifiability is actually the what do you say? It's the inherent possibility that it can be proved false. So a hypothesis, there is always a chance that your hypothesis can be proved false. Only then it will be a hypothesis. Even if it is your data, your result is indicating that whatever you have hypothesized that is correct, but as I have said earlier, that in the coming age or in the scientist will work after you, they might think they might prove that it was wrong. So only if you have hypothesized something in that way, then only it will be accepted as a hypothesis. A statement is considered falsifiable if it is possible to convince, if it is possible to conceive of an observation or a specific outcome of an experiment that negates the statement in question. Right. So that is the case that I have stated. So now, so few features of this falsifiability is falsifiability does not mean that there are currently arguments against a theory. Only that it is possible to imagine some kind of arguments that would invalidate it, right? So as I was saying, might some people might work in future and they might find that okay, whatever you were saying that was actually, or whatever you have hypothesized that was actually not correct, that is wrong. So this is the first point. Next is falsifiability says nothing about an argument's inherent validity or correctness. So it is not saying it is correct or incorrect, valid or invalid, is only the minimum trait required of a claim that allows it to be encased within a scientific manner, dividing line between what is considered science and what is not. So you understand, right? So unless it is falsifiable, your argument or hypothesis is not accepted, and then it is not. If there is no scope of wrong or error, so then it is not science. Then you are giving something, some what let's say some gyan that you are providing, but that will not be accepted as hypothesis. Whatever we tell, like folk tale, so you cannot if something like that we say for the sake of argument, like if you look at or to the many facts of our country that is going on, that has been going on for a long time. So then from that you can understand many people say something, but for the fact of something. So then those are not hypotheses. I am talking about some political leaders. So so they say something overriding the claims or the talks of some scientists, but those will not be. So they give some different hypotheses. I'm just telling for the sake of argument. So but then that will not be accepted, right? So another important point is that falsifiability is not any claim that has yet to be proven true. So it is not a claim that you have to prove true. After all, a conjecture that has not been proven yet is just a hypothesis. Say your hypothesis might have not been. So let's say you have hypothesized something. So for your hypothesis to be proved, you have to go from A to D. Between that, sorry, you are proving B. You have proven subset of B, but you have not proven C yet. So then your goal of D is not proven yet. But it does not mean that your hypothesis is wrong, because there is a chance of false. The chance that your hypothesis might be false, right? So then it is not talking about the whether it is proven or not proven, but only talking about that there is a scope that it can be proven wrong. The idea is that no theory is completely correct, but if it can be shown both to be falsifiable and supported with evidence that shows it's true, it can be accepted as true. So this is very important, right? So two things. So what are there? We are,
Hello, sir.
yeah,
Sir, can
yeah,
you please
please.
discuss the problems or sums with some example, means with some data? Then it might be means help us to solve the assignments.
Okay, I'll actually solve the assignments or the problems of assignment 5. Right now, I have not accumulated any data here, since these are some facts that
Since
were.
in the as I told you, means since in the assignment there are so many problems are there, so it might be helpful if you means some example
If
data and then
okay,
how
I
should I
understand.
solve those.
I understand. I understand. Okay, so then I'll, since these slides are already prepared, I'll try to say something as I'm doing uh, whatever I can remember. But then what I'll do then in the next section, I'll try to solve some more problems based upon these things. I'll relate or correlate all these things. Okay, so that will be helpful, right? So today
Okay,
only
sir.
we'll solve the assignment 5. So that will be anyway we can relate from here. Then in the next section or next session, I'll try to add some example, more examples based on these things only, or all this falsifiability and hypothesis, these things, and then you will I'll relate, and that will be helpful. I'll do that. No problem. Okay. So now coming back to here. So the last point is that, so as we are saying, that it is important to, when you are doing you are doing research, then you have hypothesized something, you're and through your experiment you have understood that your hypothesis is correct, right? So that you have proved. Now when along with that, if there is a scope, so that your hypothesis can be proven wrong, okay, then the reviewers, or who the experts who will analyze or go through your data or experiments or your paper, so they will judge it, or they will probably accept it for the for taking it as a true fact, and that will come now under the literature. Okay, so this is very important, that it will be accepted truth when, once your hypothesis is aligned with your sorry, your experimental results are aligned with your hypothesis, and there is a scope that the hypothesis is might be proven wrong. Okay. Next point is, for example, so Newton's theory of gravity was accepted as truth for centuries, because, so you can understand. So there's an example. Okay, because objects do not randomly float away from the Earth. It appeared to feed the data obtained by experimentation and research but was always subject to testing. So he, based upon some facts or his observation, he has made some given some hypothesis. Okay. Now, however, Einstein's theory makes falsifiable predictions that are different from predictions made by Newton's theory. For example, concerning the precision of the orbit of Mercury and gravitational lessening of light. So these are not actually, or these are not matching with the hypothesis given by Newton. In non-extreme solutions, Einstein's and Newton's theories make the same predictions.
Excuse me, sir.
Yeah, please.
Sir, now we have to solve our six assignments. So please, sir, give us some examples and solve there because that is related with statistical data, and we belong to a humanity background, and we don't know how to solve these things and all that. So please, sir, please make session before 8th March so that we can solve these assignments.
Before 8th of March, there are two more sessions, right?
Okay,
There are
fine
two
then.
more sessions. One is tomorrow, I guess, and other is on Tuesday. So
Fine.
I don't know
Chandrana,
because yeah, yeah,
Chandrana, Chandrana, that assignments are related to the central limits and mean and all those
yeah, yeah.
Huh.
I
and
understand. I understand. I've seen that.
probability
I
and
know.
all,
Yes,
which is
and we belong to art stream, sir, and we don't know how to do these things.
even I found it tough to solve those. If you have any idea and if you can do that first and the theoretical one you can do later, as Sheetal said, it will be very helpful.
Yeah, I understand, but the problem is that it is. I have, I mean, said these things to solve today. The assignment five. I understand your problem,
Because fifth
but
assignment we already solved, sir. Because now data already
yeah, yeah, I
that date
understand
is
you have
already
solved. But
gone.
the thing is that the
Ah,
instruction is
yes,
that
yes, yes. It will.
I
Your
understand.
session will be
Yeah,
helpful
yeah.
for us. Yeah, but still, please make that session also, sir, before 8th
So
March,
I'll
so that
what
we can able to solve that assignment also.
So I will request other TAs so that they can conduct, they can, I mean, they can do some sessions on that because since mine is done today, so I cannot, I mean, right now because for that I have to make some materials, right? I have to unless I prepare something, uh, it will be difficult because uh, how will I say something, right? So that is since
Okay.
last week we have decided to work on these things. So that is the problem. But then you can do one thing. You can write in before and whatever thing is required. So that will be helpful to me or to instructor, course instructor. Yeah,
Yeah.
because
Yes.
last day what he has done some problems or concerns regarding this week five was there. So that he has communicated to
Huh.
us and said that you please try to solve these problems. So that is the
Yes, sir.
case.
And frankly speaking, sir, it's very tough for us to solve these assignments and all that because it's all related with science stream.
Yeah, I understand. I understand.
It is pertaining
And
to statistics
yeah,
basically,
Yeah,
and
yeah. So the case is that
the
all the testing things are there and all
yeah,
the
yes, yes,
confidence
sir.
level of
measurement,
confidence.
calculating
Yeah,
the error
error.
bar distribution, those things are there. I understand. I know.
Correct, correct,
So
correct,
what is
correct.
the deadline then of week six?
8th March,
8th
that is
March,
why
8th
please
March, sir.
Okay, okay.
Till 8th
So
March, we have to solve that.
in the evening also 8th March you can take if at all is possible.
Yes.
so
But sir,
I'll
before
try.
that, you best,
Yeah, yeah,
just arrange before that, sir, because
so yeah, so two sessions are there before anyway. So tomorrow and Tuesday. So I'll communicate with them
uh,
that these are the things that people are wanting. So they might look into this. Okay.
uh,
So
yes, yes,
and
yes.
anyway, I'll
It's
try
quite,
to.
yeah, it's quite clueless when we see the session and when we see the
So is it? So
assignment.
is the whatever is taught in the course? So that is not helpful. I mean,
No, it is
No,
not
sir,
that.
no, sir. It's very helpful, but still, what I'm
Correlation
saying
is,
ki
yeah,
yeah,
correlation is there, but still, sir, problem is that ki fifth assignment we have already submitted there, no. So
yeah.
now we have to submit sixth assignment. So that's why,
No,
and
I'm
it's
saying,
related with statistical
Chandrana,
data.
I'm saying that whatever the sixth module is there, na, in
Mhm.
there and the assignment, uh, basically there is like you cannot correlate that assignment with that so easily for the people who are not from that batch.
Yeah, I understand.
Yes,
Actually,
sir.
from the coming
Yes.
sections, many these kind of problems are will be there. Like mathematical problems will be there that you have to solve, and then so
And
from the next section
and in
or
my
the
one thing is there, sir, कि in my life I'm first time, means first time I'm afraid of our exams, because it's totally means all the questions are very confusing, and we belong to the humanity background, and we are really worried about that these things, कि how can we solve and how we will able to solve these
yeah,
things
yeah,
in
yeah,
our
yeah.
exams also.
That's a genuine problem. I understand, but the thing, so that I'll request both the TAs. Okay, so two sessions are there.
Yes,
I'll request both of
So
them.
please,
At least they can give some clues or discuss some problems so that that might be helpful for you to solve the problems. Okay, but it will be difficult for me to do those things today because
okay, sir.
I
It,
am.
it's
so fine, fine, sir, go ahead, go ahead.
it's
Two.
okay, sir. Go ahead,
Yes,
sir.
yeah,
For
yeah, yeah,
tomorrow and
yeah.
on the Tuesday,
Yes,
you
yes,
please
you
inform
can.
the
Yes, sir.
TAs to
Yes, yes.
discuss
Yes,
the
yes,
problem. So
that's
please
what I've
You
said.
continue.
can
No,
conduct session in next meeting. Yeah.
yeah, yeah.
So please
Next meeting
continue.
anyway, I'll discuss that
Fine, sir.
anyway.
Fine,
By the
sir.
time
Go
I'll
ahead.
be,
Go ahead.
yeah, okay,
Yeah. Thank you.
yeah, yeah, sure. So, yeah, I understand that is a problem. Actually, I thought of that. I discussed with Sar also, but since we are going in a, I mean, like we are discussing once it is a your deadline is over, we are discussing after that. So that is the way we are conducting the sessions.
Actually, other courses, we don't find that challenge if the assignment is done later also, Chandranath. But this course, now,
Yeah, yeah,
especially
I understand.
pertaining to problems, and like we had it in week two and now again in week six. So, which is becoming a problem, like it's a clueless assignments basically when you
So
relate.
this assignment six was not popped up before the last session, right?
Um,
Otherwise, because last day I think I asked that what should we do in the next session. So you people have
no, 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 no. It didn't pop up. It didn't pop up.
yes,
It
yes,
has
yes.
not
Okay,
pop up by that
that
time.
is the case.
Uh,
That is the problem.
and maybe people might be going through the content and then they would have realized that assignment is
It
so
is
tough. Like
difficult.
I
Okay.
have realized it later. After I went through the content, I couldn't answer anything. So that is why people are requesting. You can speak to the instructor and please reschedule those prior to 8th.
Yeah, actually, rescheduling means the sessions, right? Session in rescheduling is actually a bit difficult because for that we have to talk to NPTEL, but they are very strict for. I
Or
mean,
else the content has to be replaced like with six
yeah, yeah,
things.
that I will try to convince her and the other TAs also because since this is a
Sure.
demand and this is very important for solving that assignment, so that I
Yeah.
will I'll convey, right?
Sure. Thank you so much.
Yes, yes, yes. Okay. Okay, so now today's sessions is mostly I'll go through this and then I'll solve and session five. But I thought that since some people have wrote about session five, as Sarah has told also that this might be some problem might be there. You can do this first. So that's I thought. But then okay, so this is the problem. I'll try to solve that. So we are here like however Einstein's theory makes false bubble. So in non-extreme situations Einstein's and Newton's theories make the same predictions, so they are both correct, but Einstein's theory holds true in the superset of the conditions in which Newton's theory holds. So, according to the principle of Occam's razors, Einstein's theory is preferred. On the other hand, Newtonian calculations are simpler, so Newton's theory is useful for almost any engineering project, including some space, including some space projects. So, but for GPS, we need Einstein's theory. So these are very specific. So these are only applicable to some specific sections or fact or areas. Scientists would not have arrived at either of these theories or compromise between both of them without the use of the testable falsifiable experiments. Unless there was scope of being false or being doing the experiments, neither of these or the areas have been would have been open. So this is the case. Is a simple example. Now I'll come to null hypothesis. What is null hypothesis? As we are talking about till now null hypothesis is another important factor that we have said. So the null hypothesis reflects that there will be no observed effects in our experiment. In a mathematical formulation of null hypothesis, there will be typically be an equal sign. This will be denoted by H. So what we attempts to find evidence against our hypothesis test. We hope to obtain a small enough p-value. So p-value means it's a kind of a test. It's a different testing parameters are there that we will learn in the subsequent sections, or I think you have learned in the session 6 students t test. So some those kind of, so this p-value comes from this kind of tests that is the lower than our level of significance alpha, and we are justified in rejecting the null hypothesis. So null hypothesis is basically uh, nothing but a statement that is proposed that it cannot occur. It proposed that effect does not occur, and the so that is the case. Null hypothesis always rejects your hypothesis. Okay. For example, we may want to investigate the claim that despite what convection has told us, the mean adult body temperature is not the accepted values of 98.6 degrees Fahrenheit. And our hypothesis for an experiment to investigate this is the mean adult body temperature for healthy individuals is 98.6 degrees Fahrenheit. If we fail to reject the null hypothesis, then our working hypothesis remains that the average adult who is healthy has a temperature of 98.6 degree. We do not prove that this is it. This is true. Okay, this is clear. Now coming to alternative hypothesis. So what is alternative hypothesis? Alternative hypothesis is uh, our experimental hypothesis reflects that there will be an observed effect for our experiment. Okay, in a mathematical formulation, it is considered the alternate hypothesis there will be typically be an inequality or not equal to equal symbol. Right? Earlier it was equal, now it is unequal, and it is reported as HA or H1. The alternative hypothesis is what we are attempting to demonstrate in an indirect way by the use of our hypothesis test. If the null hypothesis is rejected, then we accept the alternative hypothesis. Okay, so there should always be these two, null and alternative. The average. So examples I will not go here. So then we are coming to the basic difference of these two. First is the meaning. So null hypothesis is a statement in which there is no relationship between two variables, right? As I said, is rejected. And alternative is a statement in which there is some statistical significance between these two measured phenomena. Represents should no observed effect and some observed effect for alternative one. What is it? It is what the researchers tries to disprove, and it is what the researchers tries to prove. Okay, null hypothesis is the reverse or the opposite or the rejecting. Okay. Now, what is it? Acceptance, no change in opinion or actions, and alternative will. So, alternative means then once it is not rejected, then the alternative will come in and it will change the opinion and the hypothesis. Testing, indirect and implicit, and is direct and explicit. Observations is result of chance and results of real effect. So they are denoted by S naught, this is H1, and mathematical formulation equal, this is unequal. So these are okay. Now the basic differences between these two. A null hypothesis is a statement in which there is no relationship between two variables, and an alternative hypothesis is a statement is simply inverse the null hypothesis. That is, there is some statistical significance between the two variable or measured phenomenon. An hypothesis is what the researchers tries to disprove, whereas an alternative hypothesis is what researchers wants to prove. It represents no observed effect. So I think these are the repetitive thing. I will not go this slide in detail because this we have already discussed. So these are the basic differences of this null hypothesis and alternative hypothesis. So these are the things that are very important uh, things that I had to discuss with you all about this chapters, basically how to hypothesize and what are the aspects of hypothesis, how to disprove that, what are the different types of hypotheses, and so on and so forth. So after this, we'll try to solve the problems what we have already solved in week 5, and then we'll conclude today's session. And in the next session, hopefully, we'll discuss the session 6. And before that, I'll try to convey that so that anything something related to week 6 is uh, discussed with you. Now, okay. So these are most descriptive, as you understand, but these are very important things also. Now we will come to the questions of week 5, um, one by one, and that we'll discuss. So first is coming. The term falsifiability means. So what does this means? So there are four options. This possibility that a theory can be proved false to observations or experiments. The belief that all ideas in science are false. The belief that science does not know everything. And the idea that one can fabricate false data to establish a theory. So you understand that falsifiability simply means a theory can be proved false through the observations or experiments. So this is no need to say anything about that. I think someone had a query about this, this particular problem. I think he mailed to sir. So if any one of you have any doubts or questions regarding this, you can speak up. We can discuss further. But if not, then we'll move forward. I don't know who actually mailed, but this was informed. So I'm not very sure about that. Because this is a very easy thing to understand, but since you are saying that might be some critical things. Okay, I think no, none of you are there. So next is one has proposed a hypothesis A has found an experimentally testable prediction B. So, what will be then? What will be the case? If B is found to be true, then hypothesis A is true. If B is found to be false, then the hypothesis A is false. If B is found to be true, the hypothesis A is false, and if B is found to be false, the hypothesis A can still be true. So this is very simply, if you say, this is modus tollens. Okay, if B is found to be false, then hypothesis is false. So modus tollens says that if A is true, if A then B, if not B then not A. So it does not say if B then A, but it says if B is not correct then A is not correct. But it does not say that if B is correct then A is correct. So in that way, if B is found true, then hypothesis is true. This cannot be considered in that sense. Okay, this is then neglected. If P is found to be true, the hypothesis A is false. This is again we cannot say. If B is we cannot say anything if B is true. What will be the fate of B? This is not at all said. Here. Fourth one is if B is found to be false, hypothesis still can be true. But the modus tollens says that if not B, then not A. If B is not true, then A is also not true. A is not also not valid. So in that way we cannot say this is true, so then the two things this and b, if b is found to be false then the hypothesis a is false. Okay. uh,
Sir, I have a doubt.
yeah, okay, carry on.
Uh, is this have any relation with the null hypothesis and alternate hypothesis? Can we connect this? So at the time
Connect
of
means,
answering, I have a confusion. That's
yeah,
why
yeah. So you say what is the confusion, like in what you want to connect?
I think about the prediction is I at that time I think about the null hypothesis and the alternate hypothesis.
Okay.
So uh,
So what does
so
that say to
I
you?
answered it as if B is found to be true, the hypothesis A is false. Likewise, I answered.
If B is found to
So
be
now you
true.
told that it is modus tollens. Only
Yes,
understand.
yes. Yeah.
Uh,
So that is the
only
case.
oh, okay.
So I think now clear, right?
Yeah, okay, okay.
Yeah. Okay. So next is, so the next is, why not showing? So in previous years, previous week assignment solutions with clear explanation, then will be we can understand the problems. Okay, so please take class at tomorrow if possible. Yeah, tomorrow there will be some class. So Vangi raised hand. I don't know whether she has any point again or not. Okay, I'm moving further. Don't worry, I will convey the thing that there is some doubts or some problems regarding the assignment. So that will be. I don't know about tomorrow because we'll take the class tomorrow. He might have prepared already. I don't know whether he'll be able to do or not. But I'll try to I'll make sure that at least on Tuesday it is done. But I'll convey this to both of them and Sir as well. So. Yeah, so then the third problem is coming. Suppose a person has died and a scientist forms a hypothesis about the cause of her death. It should be based on, and the solutions are her horoscope, that is the assumption that fate had a role to play, the facts on the circumstances of her death obtained through observation, material, material processes and phenomena that can cause death of a person, and the possibility that she committed a sin in her previous birth. So you understand. So what will be? So this is a multiple choice question. So multiple answer question. So this is anyway is rejected. You understand why? Sorry. Next is the fact on the circumstances of her death obtained through the observation. Obviously, this will be true. So this hypothesis will be based on the circumstances of her death and through the observations. Third will the material process and phenomena that can cause death. Obviously, so what are the so it will be hypothesis should be based on that because you understand. And the fourth is the possibility that see combinations of these are so this is these are just you understand. So this is no way we can take these things. Now the next, the necessary features of a scientific hypothesis are it should satisfy the observational facts about the phenomena. One must have arrived at the hypothesis through deep thought. It should be falsifiable. It should have experimentally or observationally testable predictions. You understand? So, only thing that we can discard is this one. Although so first one is it should be satisfy the observational facts, of course, it should be. Second one is one must have arrived hypothesis to deep thought. So a hypothesis should not be coming from a thought, but I mean here this is kind of not a very, I would say, a very good question. But this is anyway not will it will not be considered because this is based on facts and some observation, not about deep thoughts. Okay, but anyway, thoughts has recurred to give the hypothesis. But the way the statement, the direction that statement leads to us, so then that is not correct in this context, so then this will be discarded. It should be falsifiable, so that is a very important criteria. And the final one, it should have experimentally or observationally testable predictions. So obviously, so these are the correct. Next, a postulate is, didn't discuss about the what is postulate, but I think I've read a postulate is given the scientific evident truth, a scientific case about a law of nature, a mathematical theory, and empirical observation. The postulate is nothing but a scientific guess about a law of nature. There is self-evident truth is then that is some eternal thing, that is not postulate. A mathematical theorem. So theorem is not postulate. Theory is based on some data, and an empirical observation is also postulate is something is very related to hypothesis but not exactly hypothesis. So it is scientific guess about something, a very eternal thing, although it's not a fact, eternal fact. Okay, so there is a guess, right? So then this is the answer. You understand? So this is right. Next is a null hypothesis. Is what is null hypothesis? This is saying not a hypothesis. Hypothesis about character of zero. Hypothesis about vacuum energy, and now an opposite statement of the alternative hypothesis. So obviously you can see. So this is correct. So it's not a hypothesis. We cannot say, although it negates the hypothesis, but it is, we cannot say it's not a hypothesis. It is a hypothesis, a part of hypothesis, but we cannot say it's not a hypothesis. Hypothesis about character of zero. It is not, although it is characterized by H naught, but it's not character of zero. Hypothesis about vacuum energy. This is not at all related. So this will be the case. Next is reproducibility of a scientific result implies work should result in an industry which will produce the item in large numbers. An experimental animal should reproduce. Another scientist repeating the experiment should get the same result, and the experimenter should be able to memorize the result and reproduce and in the exam. So this you also understand that what will be the answer. The first one is the work should result in an industry which will produce the item in large numbers. So it means the- so it is talking about something which you are doing in the small scale. Then when you once you apply that thing in the industrial scale or in the large scale, that will give the same results. So but reproducibility does not talk about yield. So in that case we are talking about yield. Yield means sorry. Let's say we are doing a reaction, and from A we are leading to product B. Okay. Now, if we do a reaction in a very small vessel or something that we do in a laboratory, let's we are doing in a 100 mg scale. So from 100 mg, we are getting let's say 50 mg. So this is the scale that we are when we are doing in the laboratory. Now it is expected. So this is a very important thing that let's say this experiment, this product is very important industrial, and it is done in the same pathway. So experiments, sorry, reactions can be done in different pathways for the formation of B from A. Now, let's say in the industrial scale, you are performing in the same way, but in very large amount. Okay, so here you are doing from 100 mg, there you are doing in a 1 kg scale. So 100 to 50 mg you are getting. So there should also you should from 1 kg to 500 gram you should get, but so but reproducibility does not talk about that. So that is something else. So this is not the reproducibility. Reproducibility is when you are doing the experiment you will get the same result. So yield does not mean result. Result means if you perform a if perform a reaction of x plus a, then it will lead to B. It will not talk about the yield that you okay you'll if you follow this path then you'll get this much of it. That can be varied, but if you follow this route you will surely reach to B. So that is the fact. So that is reproducibility. Okay, another scientist repeating the experiment should get the same result. So this is reproducibility. Experimental animal. So this is nothing related. This is also neglected, and the final experimenter should be able to memorize the result. So this is you understand. This is not the case. Next, uh, so this is understood, right? Now, next one, the criterion of falsifiability was proposed by. So this is who is there? This is Karl Popper. This is something to say. Next one, the simplicity of a hypothesis implies its mathematics is easy to do. It makes very few a priori assumptions. It does not require expensive equipments to test. It can be expressed in simple language. So its mathematics is easy to do. That is not the case of hypothesis. Simplicity means your hypothesis should be simple to understand. So this is then negated. Next, it makes very few a priori assumption. So the assumptions is very few, and based upon that, the hypothesis has been or it has been hypothesized rather. So then this will be correct. Does not require expensive experience. So this is not related at all. Final, it can be expressed in simple language. So which is not related at all. Although it is required, but simplicity in hypothesis not necessarily mean this. It means this. Next one is conservation of a hypothesis. What does it imply? So conservatism of hypothesis. So conservatism, I think I didn't talk. So it is based on available knowledge about the laws of nature. It is proposed by Conservative Party of England. So this is not true. A statement about energy conservation. A hypothesis not talk about energy conservation, although it may talk about, but this is very specific, so it is not true. An idea coming from a conservative family. So these are just it's not at all very good. Whatever, what should I say? Alternatives that have been provided here. That's all. So it is based on the available knowledge in the laws of nature, right? So then these are the hypotheses, or these are the conservatism of hypothesis. So these are the things that I had to discuss. I think if any of you have any doubt about these problems, you can come up. We can discuss further. If not, then I don't know what to do. I'll quickly look at the. So first, you tell that if any of you have any problem or doubt about whatever has been discussed. I hope you have correct answered almost all correctly. One, two were confusing. I understand, but others are very easy to answer. I guess.
The falsibility question was little confusing. The one which you showed second number question.
Possibility.
Regarding the postulates also, so it is doubtful because it is mentioned in the video also. It is something like axioms and postulates. They are the self-evident too. That need not require any proof.
No, they have told that it is a scientific guess for
Yeah,
postulate.
postulate is essentially a scientific guess. Always, like if you follow
But
any
sir, meaning is
proper.
showing like,
Sorry.
but but sir, meaning is showing scientific evident.
postulate is
But then
okay.
Postulate, yes, yes,
then
a
we refer this
self-evident truth.
postulate in
That
terms of mathematics, no, sir. That is related to mathematics, postulates, theorems.
No, no, I understand
and
mathematics, but it is not a mathematical theory. We have to answer based upon the alternatives you have given here, right? So a
but
it
the
is
postulate
postulate.
meaning is, sir, self-evident truth
That's why I'm
in
saying no,
dictionary
that
also.
yeah. Then when we are proving something that doesn't need any that you need not have to prove it, na. So that is what the meaning is. So whether it is related to
So what
mathematics
do you
or
mean by
science
self?
or
That
because
That
was the
is why
next
it
mathematics
is
is
increasing
called
question,
as
sir.
guess. I think
So
that is why it is called as scientific.
self-evident truth is something else. No, self-evident truth is means what has been taken as eternal truth. So that is truth, you know. But postulate is something you. So it is kind of a hypothesis. You are guessing something. You are guessing something based upon these laws of nature that has been proposed earlier. So it is not a self-evident truth. Self-evident truth is something else. I think so.
But
that needs to be
but
cleared up because
but Google is showing that, sir, ki a self-evident truth, and even
yeah,
in dictionary also that's the
yeah,
meaning.
and
No, no.
axioms and this postulate they are one thing. That is also given.
So you have to go through, if you go to any textbook or anything, any textbook of methodology, you can, I think, find. I think that has also been taught to you in the class, right? At least what I understand. So self-evident truth is something else. So that is not the postulate. Postulate is something, some guess or some guess based on this some this eternal truths. It's not self-evident truth is that is true, that is eternal truth, that is already accepted. But postulate is not always accepted. Postulate you have to give some guess, like with that way I can
But
say.
that might be true, but that is not elaborated in the video lecture. So it was the
So what does video lecture say?
precisely
Video lecture says that it is self-evident truth.
yeah.
No, no, it says scientific guess actually.
I don't think the video
It
lecture says it is self-evident truth.
says scientific guess in the video lecture.
Yeah, so that's what I have also seen. It says that it is a scientific guess, not a self-evident truth. It is very clearly written in the sources. At least I have seen. Uh, so yeah. So another doubt was with the uh, which one, falsifiability. This sorry, first question, right? Falsifiability. This one. So there was a doubt regarding falsifiability. So was the question this one, or please, was who had the doubt? Please speak out. Otherwise, it is difficult.
Yeah, yeah. This is the only question which I wanted.
Okay. So what is the confusion?
When you see the possibility that the theory can be proved false through observation or experiments,
Mhm.
usually when we talk about observation and experiments, we assume that because it's facts and data, we always say that it is true, right? But here it is opposite. Why so?
So a possibility that a theory can be proved false. See, I understand one mistake or one problem that is given, that you are, I think, making it complexing with hypothesis. So falsifiability and hypothesis are not same. So once you are talking about hypothesis, then it can be proved through true or false. But once falsifiability, it's a subset of that. So it means that the hypothesis, there is always a possibility that the hypothesis can be proved false. That is the definition of falsifiability. It can, a theory or a hypothesis can be proved false. That itself means. So what exactly were your question?
Okay, I got it. What you want to say
Yeah, yeah.
actually, what you said na hypothesis. Yeah, I think I was confused with that. So it is a
Yes.
definition of possibility basically.
Yes, yes. falsifiability is the property of hypothesis, but you are saying that hypothesis can be true or false once that is
Yeah, yeah,
tested through experiments. Yeah.
You
So
have to change the grade matrix. The
got it.
confusion is
okay. So anyone else, any other doubt? If not, then I'll try to quickly go through what are there in week six assignments. Then although it will be difficult to solve now, but I'll see. Okay, I'm trying to do that so I can see, right. I don't know why in my normal mode I could not log in. It's showing some difficulties while I'm trying to log in. So any of you is feeling to log in the course portal? I don't know.
No,
Suppose.
no, no. We can
Okay.
log in. We can see the assignments also.
Okay. Okay. I can, but it's not in normal mode. I have to.
You want me to log in and give the
No, no.
permission?
Now it is logged in. Yeah, so I can see from here. So week six
Hello.
contents are. Hello.
Hello. So
Yeah,
it
yeah.
is an assignment. No, you cannot solve it before it is
No, no. I'm not
submitted. But the
solving.
like question,
I'm not solving at all. I'm
no,
not solving at all. So
uh,
like questions will be I'm just saying
like
what are
questions
the
can be
questions.
discussed.
Yes,
He
yes,
is
definitely.
Uh,
discussing. We can discuss now. We will get some clues at least.
Yes, yes. So
That will be helpful. Please
that will be
discuss.
helpful, of course, of course. So
Yeah.
let me see what are there. I have not gone through it actually. So first question is, if you have to report the result in a paper, how will you specify the measured value round to four decimal places? So suppose you have measured the concentration of a substance in a solution by taking 25 samples from different parts of a liquid and have obtained the following data. Okay, excuse me. So then you have to give the things mean, error bar, average, x average, y average. So first is you have to calculate the mean and average. Define a range in which the true value of the concentration must lie in the 95% confidence or 95% probability. The range is x to y. What is the x range, y range? I mean the two extreme points. With what confidence level can you state that the actual values lies in the range 1.5 ppm to 1.5192 ppm down to 2
This
decimal.
will be. Yeah.
Uh, okay,
The
I'll.
first question. The
Uh-huh.
first question which is there, Chandana. Then when you say these data points, like 25 data points is being given, right, from the population, and we have to take out the mean. So it is by usual process what we take out the mean. We'll do like that, right?
Yes, yes, absolutely. Whatever you
Yeah,
do,
divided by like whatever the
yes, yes, yes.
divided by
What?
whatever the number data points are there. How do you, and error bar will also be, see, it is written error bar plus minus dash.
Yes, yes. So
So
error
it will
bar.
be, uh,
So some
so
formula are there na, to calculate the error bar. How to calculate error? So some formulas are there, right? I think it is there. It has been taught.
yeah, it is there, but
Is there.
it's not
Yeah.
very clear. Yeah.
Experimental error, how to calculate that. And for calculating error bar, you understand that mean is also required. So from that mean, some standard error will be calculated. For that, some formulas are there. I'm sure it has been taught.
So standard error, matlab you want to say standard deviation? No, that is different from
No,
error
no, that
bar.
is
No.
yeah, yeah, Jonas, that is different. But here, whatever error you are calculating, for that also some formulas are there. So for
So
that,
he has told from the mean towards your right, like it would be error bar is equal to mean plus towards x, from x to a
yes,
data
yes,
point.
yes.
Yeah,
That's
and
right.
then so it will be the same value, no, basically when you say plus minus this. Error bar is equal to plus minus mean value, it will come, right?
Error bar plus minus something. So It is
It will be
wanting.
mean value.
No, no, it will not be the mean value. Mean value is mean value. What is mean? Mean value is the average value. But error plus minus is not the mean value. Error plus minus, what is the deviation in the error? So that is calculated in different way. I think
Okay,
you just
this I
go.
couldn't get. Yeah, I went through that, but I couldn't get it. Like, what could be the error bar? How do we calculate? Because it's not straightforward in that. The concepts has been told, but what is the formula? I couldn't get really.
Okay.
And when you say X and Y range coming to the third and fourth,
Yeah, so define a range in which the true value of the concentration must be within 95% probability. So 95% probability has been given. So that is the confidence level that has already
hmm,
been given. So it has
that is
to.
1.6, 1.96
So
basically.
I'm not, I don't know what is the answer, but you have to, you have to calculate from that. So I think this
Okay.
is easy. This is not that difficult. What I see at least, this is all the standard things. Very straightforward question. Only 25 data points are there. Mean, error bar, and a range is has been asked. So this is for a particular confidence level. So they're all. I would say that equation based. So it should not be that
Equation
much.
based. Yeah, equation based, but directly the equation
Yeah,
we
that you
because
have
the
to
question
that
is
you have to come up.
the question is asked in a different manner. And
Yes, yes, that.
see when see now the fifth question, what is there with the confidence level? Can you? I
State,
can't
can you
read.
state
Yeah,
that the actual value lies in the range 1.5 ppm to 1.519 ppm, round up to. So so this is just the opposite. Here, confidence level has been set. Then you have been asked to give the range x and y, and this is just the opposite. So here you have to have to calculate the confidence level, and the area or the range has been given 1.5 to 1.5192. So this is just the opposite. If you know, if you can calculate one, you can also calculate the other one. It's simple as that, right?
yeah. Can you really tell somebody to take
Yeah,
tomorrow's
yeah,
this?
I'll definitely tell both
Yeah,
of them.
because
Whoever.
theoretical will not be that much. This is
Yeah, yeah,
required.
I understand. I understand. I'll definitely convey both of them. I mean, I cannot assure that they will do or not because that will be depending upon their preparation and all. Because you also understand, right? It needs some preparation to
Yes, yes,
accumulate these things because we are
yes.
not
Agree,
that
agree.
much. Uh,
Yeah,
uh,
because that understanding of area under the curve and from the mean, how that area
Yes, yes.
is.
We
Yeah,
we
what to suppose to
these
take.
things. One thing I can say from these things like this error bars plotting. So these things are very usual practice in any kind of scientific research. Like whoever in physics, chemistry, math, whoever whatever is doing. So these things are done. So we know the formulas. Although nowadays what we do, we calculate it in different softwares or different plotting sections are there. So if you can correctly see, okay, no, now it is not there. Like there are, you can calculate these things in different, I will say softwares, right? For that, different softwares are dedicated softwares are there. There we can plot, there we can calculate this easily because there are many things we are doing. So for that, we don't need to. We don't have much time to do that calculations one by one in the calculator or by hand. So that's why we do
Correct.
like that, but we know, we need to know the concept. So here that is been taught, you need to know the concept. If you can calculate one, it will be concept that you'll understand, and that is the fact. So anyway, I'll ask both of them if any one of them. Tuesday is what? Tuesday is 8. No, Tuesday
To
is 7.
no,
Even if 7th is, that will also work. So I'll.
or Sunday or tomorrow's
Sunday,
session.
yeah, Sunday. That's what I'm saying. That Sunday is tomorrow only. I am not
Hmm.
sure about his preparations and all.
Okay.
So I'll tell
Okay.
him.
At
If you
least this 10 questions that person is able to cover, then it is fine.
yeah, yeah, something related to kind of questions
10
or the
questions.
concept at
Right.
least. Yeah, I'll say.
Yeah, yeah.
So on that note, I will not discuss then any further. Anyway, we will discuss all these things in the next session. For my things at least, because I have to discuss. These are although we will solve, but some difficulties or problems or confusions will be there anyway. So today then we will conclude at this point. So next day we will discuss these sessions are week 6, and then discuss the problems and or what else do you want in the next session. I
You
think
can
that's it.
cover you can cover this only actually, because this is pertaining to mathematics and
Yeah,
statistics.
because
Better
if even if you
understanding.
can solve for now, it will you have to solve in the main exam. So for that, it will be anyway helpful. I'll
Huh,
try
yeah,
to
yeah. So you can repeat that
yeah,
anyways.
yeah, cover as much
If at all.
examples. If required, then
Yeah,
two
yeah.
sessions can be conducted for that also. All
Yeah, yeah,
right, then
using the
yeah, yeah.
formula, that how can we derive, like as we see in the question now, wherein you have the confidence level in percentage is mentioned, and we have to give
Yes,
in decimals,
yes,
so
yes.
or either ways, so that kind of things
Yeah,
can
yeah.
understand.
Sure, sure. That will be discussed. So okay, all right.
So
Then someone
thank
is
you
still
so
joining. Yeah, yes, thank you all. Yeah, I mean, I understand you had have some difficulties. Will face some difficulties for that, but
If we have not done so much of statistics or mathematics, no, we find it difficult, and if we are not in touch and suddenly, so, and second thing in the lectures, no, though sir has explained it theoretically, the formulas, how to
will help.
applicate that becomes a challenge. If somebody has an understanding and can tell that, it will be great.
Yes, yes, definitely. So, yeah, because in the lectures, what is done there, I mean, very broadly, all the things are described. Although
Yeah, that
very
is why one two example, if very specifically would have been told in the same manner. What is happening in natural science lectures? No, I don't know if you are interacting um, uh, with the this instructor. You can at least put that point across, that a lot of theoretical things is there. If this kind of examples, see, we have assignment directly, which are like which are marked, like which has some scoring, so if at the end of the session, if they have some examples, 3 or 4 examples, wherein it have practice examples, wherein they have the solution also, it helps to answer the assignments very clearly.
okay, actually, okay,
Maybe
I'll
not
try.
the same questions, but then
Yeah,
relative
yeah,
to
related
it
questions,
also.
relevant questions.
Uh,
Yes, yes.
yeah, because some of the courses, no, they have like that also. So they
So
have
you
practice
want
and then
that
they have assignments.
you particularly want that for these kind of mathematical problems, right? For the
Yeah, yeah, yeah. So in the course itself, at the end, 4 or 5 questions has been answered in that manner. At least we get a clue like how it is to be solved.
That only coursework.
yeah, okay.
Sorry.
Sorry, anybody said anything? One thing you
So
can do.
that if you can
Yeah,
speak to the
I'll
instructor.
speak, but the problem is that unless some students are raising questions, I don't know whether this will be looked after or not. But if there is some discussion forum, right? So in there, some people are putting questions. So that's why Sarah has called us and asked us to discuss these
Okay,
things.
I will put
You
there,
can,
because that
you can.
is, because this is the toughest one which we found it. There is
And
another
students,
courses
they
also
are,
which are
yeah, you are just solving.
Because see, they have a pro forma. They have, I mean, these courses are already pre-recorded, and they have a set syllabus. Okay, now they are discussing in the way that has been that they have decided. Now, if you now you are wanting something extra or accessory, that will be helpful to solve you the problem. So that's why these sessions are there. But the instruction was that we can solve it afterwards, after the assignment is over. If
yeah,
not,
yeah, yeah,
so
because
yeah, so
you're
that's why
solving
I'm saying that
afterwards.
if you directly talk about this problem in the discussion session, then this course instructor will be informed about that, and he will
Okay,
Uh,
I'll write back to him.
yeah, yeah,
No problem. I'll write
yeah.
back to him because that helps everyone. Because if we get
Mhm.
Already the syllabus we are
assignments
not going
there
to
only
change.
which are not marked, which are not for the scoring, and the ones which are for the scoring may have another questions, not a problem.
Definitely, definitely. Yeah. So, someone was saying anything? Let's see.
What
So
is
I
scoring
think
happens
by
when the
mistake it
somebody
is one.
does not score.
So, can you speak a bit loudly? I cannot hear properly. Hello. Uh, okay, then if no other further problems are or further queries are there, so we can conclude at this note today. So I'll surely convey that so that at least something is described in the tomorrow and the Tuesday session. So that might
Thank
that
you
can
so
help.
much.
Yes,
Yeah,
yes.
thank you so
Thank
much.
you all. So we are concluding today's session at
Thank you,
this
sir.
note. So yeah, yeah. Thank you. Thank you.
Thank you so.
Thank you. Thank you, Amita. Stopping them. Oh, yeah, thank you, Pragati.